We are back and better than ever. We are finding the vector between 2 points. What does that mean? Well, given any 2 points, let's say I have the point A right here and the point B right here, what is the vector between them? Okay, and how do we find it? Well, the vector OA is going to have a component A1, A2, which corresponds to the coordinates of point A. Same with B. The vector B is going to have component in component form B1, B2, which corresponds to the coordinates of point B. So if I want to find the vector AB, well, that's going to equal AO plus OB. Okay, let's think about that, because if I want this vector, I'm going to have to go this way, then this way geometrically. And that's the equivalent of negative OA plus OB, or OB minus OA. And if I put that in component form, I would just take the components of vector OB and subtract the components of vector OA, and I get B1 minus A1, B2 minus A2. And what that is a proof for a very simple and intuitive rule or algorithm. Vector AB is equal to OB minus OA. Basically, all I do is I take the components of B and subtract the corresponding components of A, and I have my new vector. Here's another way to look at it using transformations. You can take a look at that on your own. And again, here's another just another way to look at it using vector notation, lowercase a, lowercase b. It's the same result. If I am finding vector AB, I take the components of vector B and subtract the components of vector A. So I start with the components of the second letter, or the endpoint of the vector, and subtract the components of the starting point of the vector. So for BA, I'm going to take the components of the ending point of the vector, which are A1 and A2, and I'm going to subtract the components of the starting point of the vector, B1, B2. Very, very simple, very straightforward. So if I'm given these points, find the position vector of B from O. Whenever you see O, that is the origin. And of course, the origin has coordinate 0, 0, which means it has a vector, the 0 vector, 0, 0. So B from 0 is vector OB, right? That's a P, so let's make it a B. So vector OB. So I'm going to take the components of the ending point of the vector, 3, 4, and I'm going to subtract the components of the starting point of the vector, 0 and 0. So this is going to be equal to 3, 4. Okay, so this was A. Let's do B. B from A. So that is simply vector AB. Okay, you have to think about that. It's B from A, meaning A is a starting point. So that means I'm going to take the components of the endpoint B, so that's going to be 3, 4, and I'm going to subtract the components of the corresponding components of the starting point of the vector A. So 3 minus a negative 1, 4 minus 2, and that gives me 4, 2, for vector AB. And finally, A from C means I'm looking for vector CA. And so that will give me, okay, so I start with my ends, the components of the endpoint of the vector, so that's going to be negative 1 and 2, and I'm going to subtract the points or the components for point C, and that would be 4, negative 5. So this turns out to be negative 5, 7. Very simple. Vector CA, negative 5, 7. Vector AB, 4, 2. Vector OB, 3, 4. And don't ever forget that what this means for vector AB, anywhere on the plane, I select any starting point, I would go over 4 units and up 2 units, and then my vector AB would be this. This is A and this is B. Please don't forget exactly what this means. Okay, a little bit of problem solving, very little bit. If AB is a diameter of a circle with center at -1, 2 and B is at 3, 1, find BC. Well, BC is very simple, vector BC. That is going to be equal to, let's see, -1 and 2, and then I'm going to subtract the components of B. And that becomes -4, 1. Okay, so that's the vector -4, 1. So find the coordinates of A. Okay, well, A has coordinates A, B. Okay, so then we can say that vector CA is equal to A minus a -1, A minus a -1, so that's going to be A plus 1, and then B minus 2, minus this 2 here. But we also know that vector CA is equivalent to vector BC. How do we know that? Well, they're both going in this direction, and since they are radii of the same circle, they have the same length, same direction, same magnitude, means equal vectors. So that means that A plus 1, B minus 2 is equal to vector BC, which is -4, 1. Very simple, very easy. That means that A plus 1 must be equal to -4. So A is equal to -5. And that means that B minus 2 must be equal to 1. So B is equal to 3. So therefore, point A has coordinates -5 and 3. And if you look at these coordinates, that makes sense. We know that our answer is reasonable. Becker is out!